Let's continue our journey of 3D mensuration related to spheres, something like an orange or a ball, or a hemisphere, something like an orange cut in half. Now, this is a figure that shows a sphere. So basically, a sphere is a circle in 3 dimensions. So if we are drawing many circles in every form whatsoever, something like this and like this and like this and like this, and in any scenario, we are basically creating a sphere. A sphere has a center. A sphere has only one dimension, that is the radius. So first of all, a sphere has a center and it has only one dimension, and that dimension is the radius. So everything will be dependent upon radius. Now over here, this is a sphere that's cut into 2 parts, just like that orange. So this half sphere is called a hemisphere. So now let's talk about the formulas. First of all, I'm talking about a sphere. So when I talk about a sphere, let me just highlight this. So this is sphere. And there are 2 things that we consider. The first one is surface area, and the next one is the volume. Now keep in mind, whenever we are dealing with a 3D solid, we are dealing with a surface area and a volume. Surface area, the formula is 4 pi r square. It's 4 times the area of circle. That's also a good way of remembering it. And volume is 4/3, and there is pi, and there is r cube. Now, over here, what do you see? You see a pi. You see some constants over here. So that constant over here is 4. Over here is 4/3. And then you see a pi, and then you see a pi. And then what else do you see? You see r square, and over here it's r cube, which makes perfect sense. Because when we are talking about area, we are talking about radius into radius. So it's centimeter into centimeter, which is centimeter square. When we talk about volume, that's radius into radius into radius, that is r cube. That is centimeter, 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 that is centimeter cube. That means the formulas should make sense. People find mensuration difficult because they just focus on remembering the formula without understanding the logic. So I'm making you understand the logic. That is, this is 4 times the area of a circle. That's a beautiful way of remembering it. And there is 4, and there is 4/3, there is pi, and there is pi. There is r square, that is r cube. Now, in most past paper questions, when they feel, the examiner feels that if the formula is difficult, they give us the formula. It could be for the sphere or hemisphere. It could be for pyramid. And it could be maybe for something else, something that seems difficult. Now, when we cut it into halves, so what do we see? We see, let me draw a circle over here. So what we see is that we see a circular cross section that was not there in the sphere. So in hemisphere, we see a base area. So this is a base area, and this base area is a circle. So therefore, we see a pi r square. And this curved surface area over here, that is this thing. So this curved surface area is half the area of a sphere. So this is the curved surface area, which is exactly half the area of the sphere. So it's half the area of sphere. That means the formula for the curved surface area for a hemisphere. Let me write it over here. So let me write hemisphere over here. And let me draw a line over here. And I'm interested in surface area. I'm interested in the volume as usual. Surface area is composed upon two parts. There is the curved surface area, and then there is the base area. So over here, if I mark this, let me make it a bit thinner. So this is the base area. And this one over here, that is the curved surface area, something like this. So this is the curved area. So there is this curved, and then there is this base area. So when we talk about curved surface area, that is half of 4 pi r square, which is 2 pi r square. And base area is just separate. This is pi r square. So if it's a solid hemisphere, the total surface area is this and this added together, which is 2 pi r square plus pi r square, which is 3 pi r square. But if it's not solid, if it's a hollow hemisphere and the base is missing, that means the base is missing. So yes, there is the curved surface area that will be there, but the base area won't be there. So 2 pi r square will be there, base area is gone, therefore total surface area is just the curved surface area, which is 2 pi r square. Make sense? What about the volume? Volume is independent of whether it's solid or it's closed. It does not make a difference. Volume of hemisphere is half the volume of sphere. So let me write H for hemisphere. So we are dealing with H, which is hemisphere. So that is half of 4/3 pi r cube, which is 2/3 pi r cube. That's the formula. So if I summarize all this thing, and if I make a good box out of it, so something like this, and let me write over here, that is sphere and hemisphere. So let me make another line inside, and I'm interested in both the things, and another line over here. Okay, so let me draw a line bigger like this. So I'm interested in sphere. I'm interested in hemisphere. And I'm interested, first of all, in volume. So volume of sphere, that is 4/3 pi r cube. Volume of hemisphere, that's 2/3 pi r cube. It doesn't make a difference whether it's solid or it's hollow. It doesn't make a difference whether it's solid or hollow. Let me draw another thick line over here, like this, and let me draw a purple line. Now, in sphere, there is nothing to do with volume. So volume of sphere, that is the surface area. The surface area, let me write it, surface area. That is 4 pi r square. This is only the curved surface area. There is no base because it's a sphere. When we talk about the surface area over here, so if we are talking about surface area of solid hemisphere, that is 3 pi r square. If we talk about surface area of a hollow hemisphere, that is only 2 pi r square. So now this is the box that I'll be needing to carry out and solve further problems. Now let's look at this example, just go through it thoroughly, and then I'll start the working. Now over here, they have given us that the volume of a sphere is 4/3 pi r cube. The question says, a spoon used for measuring cooking consists of a hemispherical bowl and a handle. So this is the handle and this is the bowl. The internal volume, of course, there is a thickness over here. We are not interested in that. We are interested in the internal volume. So we are interested in this thing on the inside only. So when we are talking about internal volume of the hemisphere, the volume is 20 centimeter cube. The handle is of length 5 centimeter. So this thing is the handle. Let me choose blue color over here. This is the handle and the length of the handle is 5 centimeter. Find the internal radius of the hemispherical balloon. So now that is a hemisphere. So the volume is 2/3 pi r cube. That should equal to 20. It's a paper 2 question. Therefore, make r cube the subject, that is 20 into 3 divided by 2. And don't forget, let me just write it a bit upper. So therefore, this is 20 into 3 divided by 2 pi, 2 into 3.142. Now in exam, sometimes the examiner writes it. Otherwise, even if he forgets, use pi as 3.142, correct to 4 significant figure. Don't use the calculator value because that is too much of accuracy. You will get troubled by it. So therefore, this is 10 into 3 because 2 and 20 cancels out, divided by 3.142. So let me grab the calculator. That is 30 divided by 3.142. That is 9.54, and I'm taking the cube root. So therefore, R comes out to be 2.121. So 2.12, let me write it like this, correct to 3 significant figure. That is the final answer. Before that, I can write 2.1214. That is actually 5 significant figure. So I'll be focusing on first, second, third, and fourth. Since this fourth is lesser than 5, therefore this remains as 2.12. Now it's something about similarity. Now the second part is about similar figures. Now when we talk about similar figures, we talk about that volume of one figure divided by volume of the other figure, that is the ratio of the length in the same order cube. Now this has a volume of 20. Let me choose this. So now this has a volume of 20. A similar spoon has a volume of 50. Now this is the key word, similar. So let me underline it. So this is similar over here. And find the length of its handle. Now first of all, this is 20 over here. This is 5 over here. And then this is 50 over here. We are finding this length. So therefore, let me write it properly. I'm using blue color for 20 and 5. So let me choose blue color. This is for 20 and this is for 5. And then I'm using purple color. This is for 50 and this length is L. And don't forget to cube this. This comes out to be V1 over V2 is this much. So small volume over here. Let me just charge my pencil, hold for a second. So now small volume over here, which is 20, and then small length. This is more than double. So what is the length according to this formula? So therefore, let me simplify. So the zeros cancel out. This is 2 over 5 is equals to 5 into 5 into 5, because I need to cancel. That is why I'm writing it like this. And this is L cube. So therefore, L cube is 5 into 5 into 5 into one more 5 divided by 2. I think I'll be needing a calculator. So therefore, 5 into 5 into 5 into 5, that is 625 divided by 2. That comes out to be 312.5. 312.5. This is L cube. Therefore, L is cube root of 312.5. That comes out to be 6.786. Rounded off, that is 6.79. Correct to 3 significant figures. Don't forget to write centimeters. Centimeters is already written over here. Now let's double check the answer for this part. This is question number 1. So question number 1 is 2.12 and 6.79. So this is done. And let's now focus on this part. The question says, an open hemisphere. Now let me first underline this thing. In orange, the surface area of a sphere is this much. And over here, the volume of the sphere was there, and this was a paper 2 question. So now it says the surface area of a sphere is this much, an open hemisphere. So let me underline this thing. We are talking about an open hemisphere of radius 5.5 centimeter is used to make a metal kitchen strainer. 50 holes are cut out of the curved surface. Assume that the piece of metal removed to make each hole is a circle of radius 1.5 millimeter. Now remember the conversion. That is 10 millimeters is 1 centimeter. Because this is 5.5 centimeter and this is 1.5 millimeter. So therefore, we have to be careful. Calculate the external surface area that remains in centimeter square. Now, there are 2 approaches. I can either convert everything in centimeter from the beginning so that the final answer is centimeter square, or I can convert it later. I think this is a better approach. So let me convert 1.5 millimeter. That comes out to be 0.15 centimeters from the beginning. I think that is easier. So when we are talking about the hole, if we are talking about the hole, then radius is 0.15 centimeter and area of one hole, that is pi into 0.15 square, and there are 50 such holes. So therefore, this is 50 into pi into 0.15 square. Let me calculate this. So this is 50 into 0.15 into 0.15 into 3.142. This comes out to be 3.53475. This is an exact value, centimeter square. Let's leave it as it is for right now. That is for 50 holes. Total area of 50 holes. What else is there? Then we have the curved surface area. So let me write the hemisphere. And since it's an open hemisphere, we are only interested in the curved surface area. So the curved surface area is 2 pi r square, which is 2 pi, and r is how much? 5.5 centimeters. So this is 5.5 square. So let me evaluate this. 2 into 5.5 into 5.5 into 3.142. That comes out to be 190.091. 190.091 centimeter square. This is curved surface area. That's called the open hemisphere. Calculate the external surface that remains. So the difference is what I'm looking for. So therefore, 190.091 minus 3.53475. I have a calculator. Let me simplify it right now. Minus 3.53 and then 475. This comes out to be 186.55625. That is an exact value, but it does not say anything about accuracy except on the front page. So let me write this thing as 187 centimeters square, correct to 3 significant figures. So that is the answer over here, 187. So that is how we have completed the concept of spheres and hemispheres.